In one of our series, we look at gears in general. The way this mechanical device are designed was looked at. And finally, we looked at the forms of mechanical motion that we have today in industries. In today's series, we will be looking at helical gears. The way these gears are designed during the machining process will be looked at, and their applications in industries. Now let's get started. Just like spur gear, helical gear come in cylindrical forms in which the teeth follow the pitch surface in a helical manner, but the teeth are not parallel to the axis of rotation.
In a nutshell, helical gears are gears whose teeth are angled. So basically, the helix angle varies, but it is typically between 15 and 45 degrees. Based on this design, this ensures that more teeth will be in contact during the gear set operations.
These gears will be further connected to the shaft via the appropriate keyways. Since the desired mechanical motion has been achieved, which could be in terms of speed, torque, and the direction of rotations. Now those are basic features that come with gear set arrangements. However, there comes some features that make these gears a distinct. That is in terms of the teeth design. So because of the angled teeth design, the teeth allow the gears to mesh smoothly and quietly with less vibration, and higher torque is provided at the output.
The teeth design ensures that pressure is gradually distributed along the whole tooth. This gradual distribution is due to the tooth inclination, so helical gear sets run smoother and quieter than other gear sets of different teeth designs, and they are able to carry heavy loads efficiently.
And it is on that note that helical gear sets are categorized into different types, which are direction of the helix and the arrangement of the gears. So in terms of the direction of helix, they are classified into two, which are left-handed teeth gears and right-handed teeth gears.
Perfect. One of the things that are worth noting is that in a left-handed configuration or in a right-handed configuration, the teeth of the driven must be angled in opposite directions for compatibility's purposes.
Now in terms of the gear set arrangement, helical gear is further divided into the following, which are single helical gears, double helical gears, spiral bevel gears, and hypoid gears.
Single helical gears can also be known as left-handed teeth gears or right-handed teeth gears. This is because of the helical teeth design that these gears have.
So single helical gear could either be left helical gears or right helical gears, but not in both configurations.
Double helical gears, on the other hand, can also be known as herringbone gears. This gear consists of two teeth designs which can be in the same direction or opposite directions. And it is based on this design that helical gear was primarily designed to overcome the disadvantages of the high-end thrust that occurs with single helical gears.
To further look at it in a layman's terms, when the combination of two helical gears of opposite-handed teeth are brought together, the end product is what is known as double helical gears, or herringbone gears.
Spiral bevel gears have their teeth designed in helical forms. This gear are used to transmit motion and power between non-parallel shafts. And the teeth on spiral bevel gears are usually inclined at an angle to the face of the transmitting gear.
That said, because the gears are arranged at an angle to each other. This gear set's arrangement allows them to transmit motion and power at an angle, thus making them suitable for applications where the shafts are not aligned.
Hypoid gears also come in spiral bevel gears forms, just that their teeth are usually offset from the center of the gear. This allows the gears to have a higher gear ratio and a larger contact area between the teeth. This gear set arrangement increases their load carrying capacity and efficiency.
In terms of design, it is similar to spiral bevel gears, just that hypoid gears come in a cone-shaped gears, and the mating axis does not intersect during the gear set's arrangement. So basically, the gear shaft which is on the pinion side is usually offset from the larger shaft which is the hypoid gear side. Overall, there are several different types of helical gears. Each of these gears are suited for different applications and operating conditions, which are in automotive transmissions, aerospace, industrial machinery, and robotics.
In automotive transmissions, they are used to transmit power from the engine to the drive wheels. In aerospace, helical gears are used in many aerospace applications, such as aircraft landing gear and satellite control systems. In industrial machinery, helical gears are commonly used in industrial machinery, such as conveyor belts, mixers, and pumps. These gears are used to transmit motion and power between different machine components. And finally, in robotics, they are used to provide precise, smooth motion and power transmission between different robot parts.
All these make helical gears to be a more versatile component that is widely used in many applications where smooth, quiet motion and power transmission are important. For examples, the teeth design which are inclined at an angle to the face of the gears makes the gears to mesh smoothly, and offers a quiet gear set operation. The other one is versatility. Helical gears are used in various applications, which range from what was mentioned earlier. These are from automotive transmissions to industrial machinery and robotics. This versatility makes them a popular choice for many different types of applications.
Helical gears offer high load capacity, which means they can transmit high amounts of torque and power without failing. This makes them suitable for use in applications where high loads are present. Finally, helical gears are more efficient than other gears. This is because the inclined teeth allow for a more gradual transfer of power from one gear to the other. This reduces the amount of power lost as heat and increases the system's overall efficiency.
However, these gear design comes with their own drawback, which are more complex manufacturing process. This is due to the inclined teeth on helical gears, thus making them more difficult to manufacture than other gears, such as spur gears. And as such, these complexities make helical gears to be more expensive to produce and sometimes limited in availability.
It also comes in limited sizes. This is because of the complex manufacturing process. Helical gears are typically only available in a limited range of sizes. This can make it difficult to find the right size gear for a specific application.
The inclined teeth on helical gears tend to generate a high axial thrust force which the bearings and other components in the system must accommodate. So there is a need to use special bearings or other components to support the gear sets. This will in turn add to the cost and complexity of the system. And that is it on today's series. In the next video, we will be looking at bevel gear sets. The way these gear sets are designed will be looked at, and their applications. I hope you have learned something new today. See you at the next one.